Hi grade 9s, welcome back to another one of our video lessons. So today we're going to continue with constructions of triangles and different angles. So we are on page 114. So let me just turn the volume down. Okay, so we are on page 114. So we're going to continue with the next worked example. So I'm going to work through the next two worked examples, and that will take us to another worked example and then exercise 12.2. Okay. All right, so again, I want you to work with me through these examples. Don't just watch me do it and look in the textbook. I want you to actually do this, okay? It's good practice. Right, so at the top of the page, it says a unique right angle triangle will be constructed if any two of the sides are given. Remember, it's a 90-degree angle, so we already have that. We need to have any of the other two sides and we'll have a unique 90-degree angle. All right, or sorry, triangle. Right, so example says number 1, without using a protractor, construct triangle ABC if B equals to 90 degrees, BC is 12, and AC is 13. All right, cool. So we need to, before we start, we need to understand where each letter is and where's the angle and what is our positioning. So they tell us it's a triangle ABC with angle B being 90 degrees. Okay. So remember, how do we start all our constructions? With a construction line, then we measure off one distance, and then we went to draw a perpendicular line. So essentially, I want to put my 90-degree angle over here. So what I'm going to say is that I'm going to draw a construction line like that, and I'm going to call this point, what do they do? Okay, let's measure. They tell us the distance of BC. BC is 12 centimeters. Okay, so what I'm going to do is I'm going to mark this off B and C, and this is 12 centimeters. So draw my solid line in between. Okay. Right, now we need to construct a 90-degree angle at B. Okay, how do we do that? Well, in order to construct a 90-degree angle at a point, we need to step away from the point the same amount. Then once we have these two marks, we're going to put our needle compass, make a mark here, make a mark there, make a mark there, and we'll get a line going through that. Okay? So what I mean by that, put your needle compass at B, open up your protractor not too far, maybe 2-3 centimeters, doesn't matter. Make a mark there, make a mark there. Okay. Now what we're going to do is we're going to put our needle compass point into here and into there. We're going to open up our compass some distance, maybe that distance, maybe a little bit bigger. And we're going to make an arc there. You're going to put the needle point there, keeping the same distance as here, make an arc there. Now, if you guys want to be extra accurate, right, what you can do is rather than just connecting these two dots, right, you can also make, while you're making this arc, you can come down and make an arc there. And the same thing here. Once you're making that arc, come down and make an arc there. So now you essentially have 3 points to go through your straight line. So mine's a little bit off. I'll make it better. Okay, something like that. And then we put our ruler through all of these 3 points and we draw our vertical line at B, which is 90 degrees. And we can also show that. There it is. Okay. So we have BC. This is obviously A. Right. What else do they tell us? They say BC is 12 and AC is 13. Okay. AC is 13. Okay. So how are we actually going to find this point? Right? Well, it's pretty straightforward, right? We know that AC needs to be 13. We're going to open up our compass at 13, and we're going to put our needle point in here, open it up at 13, and we're going to make a mark like that. Okay. Where the intersection here happens, that's where this line and this line join. Okay. So then this will be like that, and this is 13. Okay, and that's our point A. Right. Okay, we're getting there, guys. Okay, so that was number one. Number two, determine AB by using Pythagoras and then check your calculation measuring AB. So they want us to find AB using Pythagoras. Remember, Pythagoras says that the hypotenuse squared equals this side squared plus that side squared. Okay, so we're going to work it out and then check our answer if we are correct. So let's work it out. So we'll call this side x. So 13 squared equals to x squared plus 12 squared. 13 squared is 169 equals to x squared plus 144. Okay, well, we need to isolate x. We have x squared, so let's take this 144 to the other side. Okay, so therefore, and then I'll flip the two sides around. So this will go to the left. The x will be isolated on its own. So I'm going to say x squared equals 169 minus 144. Okay, guys, I don't want you to get confused where I flip the equation around, because the convention, we want to have the variable on the left-hand side. So when we write our equation like this, sometimes, you would write it out like that and your variable will end up on the right. So once I take this 144 to the other side, you can see that x squared becomes alone. So at that stage, I'm just doing this to the equation. I'm literally flipping it around. So if I say to you 1 plus 2 equals 3, I can also say 3 equals to 1 plus 2. Okay, that's all I'm doing. Rather than me taking the term over for it to become negative and then that one to become negative, so now both are negative, and now I have to multiply by a negative to make them positive. What I do is I just flip it around. Okay, similar to what I've done here with the 1 plus 2 equals 3. All right, so let's continue. Our x squared equals 169 minus 144. That is going to give us 25. All right, put this 13 inside so it doesn't confuse us. So x squared equals 225. Remember, how do we find x from here? Well, we need to get rid of the square. How do we get rid of the square? We have to use reverse operations. Reverse operation of a square is a square root. What we do to one side, we have to do to the other side. So let's do that. We square root x squared and we square root 25. The square root and the square cancel, giving us x, which is root of 25 is 5. 5 what? 5 centimeters. Okay. So now we've worked out that x equals to 5 centimeters over there. Now take out your ruler and actually check, is it 5 centimeters? How close did you get it to be 5 centimeters? Well, by us using these compasses and rulers and construction lines, we are very precise. This isn't like sloppy work. This is precise precision work. So when you're measuring, you should be getting 5 centimeters. You should be getting 4.9 at the very worst. Okay, if you're getting anything less or more than that, you need to do this again and work through it carefully. Guys, remember, this is almost like technical drawing, right? It's not just sketching a graph. It's making it perfect, like you're drawing a house plan. When the builder looks at that plan, he's not like, oh, is that wall a bit skew? Or yeah, there's like 2 millimeters off. That's 20 extra centimeters that this wall is going to stick out on the side of the house. No, it needs to be perfect. Okay, so the same thing for this section. When you're going to write and answer questions on this, I'm going to sit there and I'm going to measure. And if you are off more than 1 millimeter on either side, I'm going to mark it wrong. Okay, guys, so please take care doing this carefully and get into your mind that you need to do this very carefully and focused. Okay. All right, cool. But it's not so hard. It's just a bunch of lines, guys. Just work carefully. Think what you're doing. Let's continue. So number 3, extend AB to D. Okay, so AB, we want to extend it to D. Remember, this mark was done for extra accuracy, but we can also use it to extend this line going straight down to D. So we'll call this point D. There it is. Then they say to us, extend BA to F and AC to E. BF, so no, BC to, sorry, BC to, BA to F. So BA, we extend it to point F, there it is. And they want us to extend AC to point E. AC to point E. Okay. Now, guys, if you are wondering which side am I extending this, why didn't we extend here, and why did we extend there? The direction is given to you by the letters. So they say extend line AC to E. So the line AC starts here at A, continues to C. Now we must extend it, means go past C to point E. If I wanted you to extend this side, I would say extend line CA to E, and then it would swap direction. Okay. All right, cool. Let's continue. Show that each exterior angle of triangle ABC is equal to the sum of the interior opposite angles of the triangle. Okay, so here, have they given us any angles? The answer is no. They haven't given us a single one of these angles for us to use. Okay, but we have to show. So they didn't ask us to construct. So here you can use your protractor. Okay. So what you need to do is you need to measure these two angles over here. Okay. Once you measure these two angles, you need to show me that the exterior angle is the sum of the two interior angles. So basically, you need to show me that this angle here equals to that angle plus that angle. How are we going to do that? Well, easy. You're going to measure this angle, that angle, that angle, that angle. So you're going to measure all these angles. And then like in the previous exercise, you're going to tell me, right, angle FAC, this angle, equals to, FAC equals to 113. Okay, so this is 113. Then you're going to say, well, angle ABC plus angle BC, no, angle ACB, so this and this equals to 113 because you're going to do them separately. And then in the next line, you're going to say, oh, both of them are the same 113. Therefore, angle FAC equals angle ABC plus angle ACB. Okay. Guys, we did the similar exercise in the last example that I went through with the exterior angles. It's exactly the same thing. So the solution is at the bottom there, number 3. So they show you exactly that. They show you each one, they show you the two added, and they conclude that yes, the two are the same. All right. Okay, number 4. What do you think the sum of exterior angles will be? Check your answer by determining the sum of exterior angles. Okay, remember from yesterday we said that the sum of exterior angles will add up to 360 degrees. So here you can maybe take a guess, say maybe it will equal something else, maybe it will equal to 360. And then you need to add the exterior angles up that you've just worked out. And if you look at the solution in number 3, they list those 3 exterior angles right in the beginning. So FAC, BCE, and DBC. So if we add all those angles together, you should get 360. Now, let's say you add them all up and you get 361. Okay. That's obviously a mistake. That's obviously you over measuring some angle or under measuring another angle. Okay, so if you are off by 1 or 2 degrees when you're adding all these exterior angles, know that you shouldn't be off. Okay, which means that go back and remeasure one of the angles and make sure it's exactly that. Okay, and if say one angle you measure and it's 55.3, make it 55, and the other angle is say 23.7, make it 24, so that you round them off in such a way that added together, they will give you 360 degrees. Okay. All right, cool. That is that example with the right angle. Let's look at the next page, 115. So it says this angle is called the included angle. If the non-included angle is given, so that, oh, sorry, I started at the top. The page starts on 114, so I'll start there. If two sides of a triangle are given and only one angle, which is not equal to 90 degrees, the position of the angle is very important. So what they're trying to tell us here is that if we have a right angle triangle, we only need any of the other two sides to construct a unique right angle triangle. Unique means there's only one of a kind with those particular measurements. Okay. But now, if they say that the angle is not 90 and they give you two sides, it's very important where that angle is. Okay. Because if we give a non-included angle, which I'll explain what that means, then that means we can construct multiple angles with those same dimensions that they're giving us. Okay, so guys, what we're really building up here is congruency conditions. Okay, we're going to get to it just now, and we are constructing this. We're learning about triangles, but it's all building up to something. Okay, right, let me show you what an included angle is. Okay, so let's say I give you a triangle that looks like that. Okay, so there's our triangle. What I'm redrawing is the little diagram on page 115 in the top right corner where it says keywords, included angle. So let's say I give you this angle over here, all right? And I give you this side here and this side here, okay? So if I give you two sides where the angle is wedged between the two sides, then that means that we're going to have a unique triangle, meaning that with exactly the same measurements, we can't draw another triangle, okay, that will look different to this one. But if I give you this angle, that side, and that side, this is not an included angle, because an included angle needs to be wedged between the two sides. Okay, so it needs to make like a connected three-piece thing, right? So side, angle, side. In the previous example, we had two angles and a side in between. So again, it's connected, therefore it makes a unique triangle. Okay, so here they are not connected. Okay, the angle or the side needs to be wedged between the other two sides or angles. So what I mean by that is that here, in this example, we have an angle that's between the two sides. So that makes a unique triangle. If we had, let's say I've given you two angles, that angle and this side, that would also make a unique triangle, because now the side is wedged between the two angles. Okay, guys, that is the congruency conditions for triangles. Okay, so meaning that to see if the triangles are the same, they need to follow the same pattern. Okay, if the pattern's not the same, the triangles are not equal, because then we can have other triangles with that look different that have the same measurements. Okay. Right, so again, an included angle is an angle that is wedged between two known sides like that. Okay, so that's an included angle. This angle over here is not included because we have this side, but we don't have that side. Okay. All right, guys, so I think we'll leave it at that for today. No homework again, but I want you to work through these examples as I have. Okay. In the next lesson, I'm going to continue with the next worked example and the one after that. And then after that lesson, we're going to have some homework, which is exercise 12.2. Okay, cool, guys. I hope you enjoyed it. I hope you're enjoying the homework-free week. Okay, take care. I'll see you next time.